Now we're getting to the good stuff. We're going to look at the different types of indexes that occur when you want to execute queries. And we're also going to create an index to illustrate the performance improvement that you can gain. So, first up on the chopping block, single column indexes. Single column indexes are indexes that are used against the most frequently used column in a query. The most frequently used column is often the column that you are referring to in every single query in the where clause. So that's the column that you are going to apply an index against. Then we have multi-column. Multi-column is the same as single column, but you're applying it against a group of columns in a query. So multiple columns. The important distinction here is that it really depends on how elaborate your where clause is. When you use a multi-column index, you're using it against multiple columns. So you're using it against columns that happen to be used in multiple queries in the where clause. If you're filtering against, let's say, a category and a type, which in essence are kind of the same thing, but let's just say for nuance sake that you had a table where you had a category and then a category type. Well, then let's say you had a where clause and you had 100 queries that were using those two and they didn't happen to be indexed in any way, shape, or form. Well, you're going to use it against that. Then you have the decision to make of when you're going to use a specific index. So when are you going to use single column? Well, if you're retrieving data that satisfies one condition, so you're always trying to satisfy one condition, then you're going to use a single column index. Multi-column is when you're retrieving data that satisfies multiple conditions. Again, a where clause that is trying to apply against multiple cases. You're having ands or ors, stuff like that. Then next up are the unique indexes. Unique indexes are for speed and integrity. When you create a unique index, you are also creating an integrity check. You usually create it against columns that can be unique. So always use a unique index against a column that can only contain unique values. And these are built for speed. Next up, the partial, an index over a subset of a table. So this one is interesting. When you create an index, you can create an index with a specific name on a table, and you can give it a specific expression. You could say, hey, do it only where the salary range is over 5,000, for instance. You can apply an expression like that. So the partial is over a subset of a table. Now, then we get into the implicits. Implicit indexes are created by the database. The database automatically creates these. When does it create them? Well, let me give you two examples right here, right now. When you create a primary key or a unique key, so you flag a column as primary key or you flag a column as a unique key, the database is automatically going to index these. Why? Because it's a good, solid decision that you should always apply. So the database is already going to do it for you so that you don't have to worry about it. All right, so let's create an index just to showcase. Over here, we're in Valentina Studio. And you can see that I have a query where I'm selecting the name, the district, and the country code from city in the world database. And I'm applying a filter. I'm saying where country code is in TUN, Belgium, or the Netherlands. So I'm applying it against specific country codes. And as you can see, I'm getting 8 back. But there are a ton of records. There's 4,000 records in here. Now, you may think, well, this query executes relatively quickly. Let's look at it real quick in detail. Explain, analyze. A keyword that you can put in front of any query to explain or analyze the execution of that query. And if we execute that, what we're going to see is we're going to see the query plan. What it's going to do, it's going to scan on city. It's going to filter based on our filter here. And it's going to remove rows that don't match. So it took 0.115 milliseconds to plan, and it took 1.3 seconds to execute. Now, if we look here, and we look at our schema, and we look at city, the table specifically, we can see there are no indexes on this table. So there are no indexes. This column is not indexed. nor is it unique. It's not a unique column by any measure, but it took 1.3 seconds to execute. Now let's say we created an index against it. Create index, and let's call it IDX country code. And let's do it on city. And then let's do it on the column country code. All right. When we do that and we execute this, and then we go here and we refresh, we'll see our IDX country code. Now let's execute that same query again with the analyze. And what we can see is that our query plan changed. Why did our query plan change? Well, it's using the index. It's using the index to apply the condition to. So even though our planning time stayed the same, our execution time went from 1 second, 1.3 seconds, to 0.3 seconds. That's a massive, massive, massive gain. And so indexes can really, really speed up queries. But again, you have to take into account when and how to make a decision and what to index against, because insertion against this will make it very difficult for us to update and continuously change, because now the index needs to be updated. And it's not to say that it's a super, super heavy operation in this specific case, but it can be. And if you have millions and millions of records, creating an index can take a long time, for instance, depending even on the type of data that is stored in that index. But what we see here is very clear cut. Index speed up our queries. We just need to be smart about them. Now let's look at creating a partial index, for instance. Now this is going to be a very contrived example, but let's quickly delete our index that we created. And let's say that we went ahead and we created that same index. We create index IDX country code, and we do it on city, and then we do it on country code. But then we say where country code in, and let's take our 3 examples here, and let's do it against those. So let's execute this. And now what we have is a partial index. So it's only going to index the ones that appear in this list, which will optimize for our query. Let's see what happens when we execute our query. So let's take this and let's do a select country code from, and then let's do city, and let's do our where clause again, and let's take some other stuff. Let's do name and district. So let's select name, district. And as you can see here, name is a reserved value. So, we'll put it between double brackets just so that we reference it correctly. So here we can see this. And if we run our explain analyze, of course, our query execution time is going to be extremely low because we've indexed specifically against these 3. But let's throw a wrench in there and let's take PSE and Sweden, and let's take the USA. And let's see what happens here. Our execution time is 1.9 seconds, and that's because our index is partial. But what if we threw Belgium back in there? Well, it's not really going to matter because the index is against those 3 specific values. If we went ahead and we deleted our index again, and we just applied our index fully, we said, let's create our index again, and let's say IDX country code. And we're doing it again on city, and we're doing it against country code. So we're going to create the full index now. And then we run it again. Well, we'll see that it goes down. It's not 1 second anymore. So partial indexes go against what you would consider a part of that column. So a part of that column is going to be indexed. And when you run a query against part of that column, that part is going to execute extremely fast. But if you change the criteria in your where clause, well, then it's not going to use the index to search, of course, because that part is not indexed. So it'll slow down again. So hopefully you can see the benefits of creating indexes here. But there's one more thing we need to take into account. These indexes we're looking at, well, You know, when we look at how computer science works, usually when you create a table of contents and you're creating search algorithms and you're searching and you're filtering, there are specific algorithms that we use to optimize for certain scenarios, because a different way of searching may yield quicker results depending on the situation you're in. So let's look at some of the algorithms that can be used for indexes.